Welcome class. Thank you for joining me for the beginning of chapter 7. So chapter 7, we're transitioning to working with exponential functions. So basically now, instead of the base of something being our variable, now our exponent is going to be the variable, the thing that's changing. Now, today and tomorrow, we're going to be basically exploring the graphs of these. Transformations, the basic shape, all that kind of stuff. Now, the graphs are actually pretty easy this time because it's not like lines or parabolas or anything like that where there's a set of rules to make it. Basically, the only thing you have to know in order to make it is how to make a table. So if you notice, in order to graph exponential functions of the form y equals a times b to the x, you want to make a table of values and you're going to plot and connect the points that you make in the table. So here are two examples that we're going to be running through. Now, I've got the table started for you. So basically all you're doing is choosing some nice values, a couple negative, 0, a couple positive, just to get an idea of what is happening. So y equals 2 to the x, and I'm going to plug in -3 for x. So basically we have 2 to the -3, or what your calculator is going to tell you is 1/8 or 0.125. If you plug in -2, so 2 to the -2. Again, plug into the calculator, see what it says. It'll tell you 0.25. And actually, I could be plotting these as I go. So now these fraction ones are kind of difficult. So really to do the best you can when it comes to these. 2 to the -1st power. That's going to give you 0.5. 2 to the 0, well, that's a property we should know. Anything to the 0 power is just 1. 2 to the 1st power. Anything to the 1st power is itself. So we get 2. 2 squared, now that's what everybody should know. 2 squared is going to give you 4. To the 3rd power, again, after last chapter, you should know this like the back of your own hand. 2 to the 4th power is 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so look at this shape. So nothing that we've really graphed before, nothing we've seen before. It's not a straight line, but also not a parabola, radical, anything like that. This is going to be a brand new function. Now, after you plot those points, you can make your curve with it. All right, so there's the basic shape. Now, we have a couple questions to ask about, okay? There's a lot of ways that we can analyze this information. So let's begin with the y-intercept. That's a common thing to ask for after graphing. So y-intercept, we're looking for where does the graph cross the y-axis. You can either look at the graph or at the table, and you'll see that it's crossing at 0, 1. All right. Asymptote. Now, this is a brand new word to you, okay? You've probably never dealt with something called an asymptote before. Now, I'm going to scroll down just ever so slightly because right underneath this, I put a definition of an asymptote. An asymptote is a line the graph approaches as x or y go to infinity. All right, so what do I mean by that? Well, I want you to look at this. As x goes off to -infinity, notice that the values are going to be approaching 0, getting closer and closer and closer. Because as you get a more negative exponent, again, you're getting closer to 0. You'll never reach it. However, you're getting ever closer to that line. All right, so in this case, we are approaching a horizontal asymptote. And where is that horizontal asymptote? Well, that horizontal asymptote is sitting at the line y equals 0, which also happens to be the x-axis. All right, so for every one of these, we're going to determine Where is that horizontal asymptote for these graphs that we are graphing? All right, we want to know the domain. Now for exponential functions, domain is actually really nice. The domain is going to be all real numbers. You can put in any number you want for x, and you're going to be able to get a calculation for it. So no restrictions with our domain, all real numbers. However, the range is something more interesting. For the range, what are we doing? Well, if you notice, we're dealing with all y values that are positive, all y values that are greater than 0. Now, I do want you to be careful here, because in this case, it is all the y values strictly greater than 0. Because again, note, we had this conversation. Y is never going to be 0. Doesn't matter how negative that exponent gets, you're never going to pop out a 0 number, okay? So when you're doing the range, it is actually strictly greater than 0. But you can't do greater than or equal to. All right, and for the range, or not range, I apologize. For growth and decay, growth means that as x increases, it's going to be exponentially getting bigger. Decay means as x increases, that y is going to be decreasing exponentially. So I think you can see here, definitely an increase, definitely going up. So this is going to be an example of a growth function. All right, so let's do another example. So looking at our next one, this time we have y equals 1/3 to the x. All right, so this time please be very, very careful when you're putting these into the calculator. Now note the parentheses that I use, okay? If you don't use those parentheses when you put these in the calculator, you're not going to get the right answer. Okay, so please, please, please be very careful. So for the first one, we're taking 1/3 to the -3 power. And again, you must use those parentheses. If you aren't using those parentheses, there's a very good chance you're not going to get the right answer, that it won't calculate it correctly. 1/3 to the -3, you actually end up getting 27. You end up getting a huge number. Well, because again, keep in mind that negative exponent would be flipping that 3 up before you take the exponent. So again, it makes sense that we're getting such a large number, okay? If you think about it in terms of what we know about exponents, it makes sense. All right. 1/3 to the -2 to the -2. Well, again, it shouldn't surprise you that negative exponent will bring the 3 up before you square it, so you are actually going to get 9. All right, 1/3 to the -1 power. Now this time is just going to bring the 3 up to the numerator and then not change anything. All right, to the 0 power. And again, we know what the 0 power means. Anything to the 0 power, we are getting 1. Anything to the first power, we're getting itself. Now, in this case, I'm going to put it as a decimal just because for graphing purposes, things are usually better when they're decimals. So I'm actually going to put it like that. All right. To the second power, that'll give us 1/9 or 0.11, repeating. And to the third power, you get 0.037, repeating. All right. So there's my table of values. Now let's see. -327, way off my graph. So I'm going to start with -2, 9. Then -1, 3. 0, 1, 1, 1/3, 2.11. And again, you get the idea that now it's going to be getting ever closer to 0 without actually hitting 0. And again, it's difficult to graph that where it doesn't actually look like it touches my axis, but hopefully you can understand while the graphing it is difficult that it will never actually touch or cross. So let's take a look here. Answer those same questions. The y-intercept. Well, the y-intercept is going to be 0, 1 again. You can see that from the graph or from my table. Asymptote. Where's my asymptote? Well, this one is the same thing. Again, sitting at y equals 0. Domain, I told you, all real numbers. There's no restriction on the x's you can use. But on the y's, again, notice we're only getting positive numbers. Growth or decay? Well, this time I think you can see what's happening. It is exponentially decreasing. So that is going to be exponential decay. All right, so that's how we deal with the graphing of these, all right? So piece of your worksheet tonight is going to be graphing these various functions. Now, here's a nice little flow chart to kind of summarize a bunch of the things that we just talked about. So, oh, somehow the x did not record there, so that should be y equals ab to the x. You can add that in, please. So, here, a and b cannot be 0. B is a constant, x is going to be our independent variable. Growth and decay, now you saw examples of this, okay? So asymptote is going to be a line the graph approaches as x or y increases in absolute value. Well, the y-intercept, here's something interesting. Y-intercept is at 0a. Now this is something you're going to get a little bit of practice with on the worksheet. These examples didn't use it. However, the y-intercept is going to be any multiplier you have on the outside. So that vertical stretch is going to manipulate your y-intercept. And we're going to see that in just a second, but something you didn't graph yet. Domain is always all real numbers, and the range y is greater than 0. So this page is really just a summary of the things we've already talked about. All right, so let's take a look at these. So we're going to be identifying key features of the exponential equations without graphing it, okay? Because these things can tell us a lot before we ever have to graph it. Because you don't want to have to graph everything. It's usually not our favorite thing to do when we're looking at equations. So the things I need you to pick out in these equations, the y-intercept is at 0a. That a, that multiplier, is going to be controlling the y-intercept. So, growth or decay. So it is growth. Now here, let me write this so you know what I'm talking about. It is growth when this number here, this b value, the thing that's being influenced by the exponent, when that is greater than 1, it's going to be growing exponentially. If it is between 0 and 1, so a fraction or a decimal or something like that, that's when you're going to get your exponential decay behavior. Now, I do want you to watch out for one thing. When the exponent is negative, so when you have a negative x sitting in your exponent, you want to flip it before you determine if it's growth or decay. And then the percent growth or decay is the difference between b and 1, and we're going to be writing that as a percent. All right, so again, kind of a lot to take in, but once you see some examples, I think it's going to make more sense. So let's run through these. Y equals 2 times 1.3 to the x. So the first thing we want to note, is this growth or decay? I determine growth and decay by looking at that number right there, that b value. All right? It is greater than 1. So that means we are going to be talking about growth, because that value right there, again, is greater than 1. The y-intercept, Now I'm going to be looking to that 2 for my y-intercept. Remember, that multiplier controls my y-intercept. And percent growth and decay. So remember, percent growth and decay, again, we're looking back at this number again, and we're looking for the difference between it and 1. So 1.3 minus 1, well, that difference is 0.3. However, note it says written as a percent. So remember, 0.3, the decimal, written as a percent, would be 30%. Remember to go back and forth. You move your decimal place twice, and you would get 30. All right, moving on to the next one. So we're looking for growth or decay. Well, here notice 0.65. That is less than 1. So less than 1 means we're talking about decay. Y-intercept, I'm going to be looking at that multiplier right there, that 0.5. So that's going to change my y-intercept to 0.5. And the percent growth and decay. So I'm looking for the difference between 0.65 and 1. Well, that's a difference of 0.35. And again, written as a percent, move my decimal place twice. That's going to be a decay of 35%. Now this last one is the interesting one. So that note that I gave you of watch out for negative exponents. So this is exactly what I'm talking about. Note how we have a 5 to the negative x. We don't want to leave it written that way. So I'm going to take that negative x, and I'm going to say, all right, I realize that that's shifting that instead of 5, it's going to move it to be a 1/5. That negative will take that 5, move it to the denominator. And what is 1 over 5? Well, 1 over 5 is 0.2. So that would be how I would tackle this, okay? Because now it looks like all of the others that we just did, and we can properly calculate this. Now that number, clearly less than 1, so we're going to be talking about a decay situation. The y-intercept, look at that multiplier, that a value. So my y-intercept is going to be 0.6. Percent growth or decay, well, I look back to this number, to 0.2. It has a difference of 0.8 from 1. All right, but to turn that into a percent, move that over. So that's going to be an 80% decay. All right, so thank you so much for joining me for this first video of Chapter 7. So please make sure you have all of this written down and then come back to class prepared to begin our practice work.